Just one more able to finish a little early today and leave the rest of class for lab time to work on chapter 6. Because I want to save all of the searching and sorting algorithms for next time, which are super cool, and I suggest that everyone takes a look at those before we meet back up on Wednesday. So just in the book, just to kind of familiarize yourselves with just the concept behind them. And then what we'll do, not to scare anybody, is we'll work together to make our own versions of these. And it's really no big deal. We'll see that we can write our own selection sort and our own sequential, right? Our own selection sort and our own binary search algorithms. Actually, I think we just, selection sort, binary search. That'll be good. Okay. But for now, let's think about a different search algorithm, one that's actually very easy to understand. So if we wanted to pick on, for example, on today, we could pick on today. And here we've got just in this kind of first, like the first two sections here. To see to start it, Kadria to ask, Kadria, are you on? And Kadria would have to say, no, I'm not. And so then we would move on to Jorge. And we would say, Jorge, are you on? And Jorge would say, no, I'm not on. And then we would move on to on. And we would say, are you on? And on would say, yes. And so then we would know, okay, here we have found on. And it was at, the third kind of algorithm would say something like in this, in these, for these three students, on is at position 2, meaning, it's position 0, 1, and 2. So we found on, which is at position 2. If on wasn't there, so maybe we were looking for Reza, we could ask Kadria, are you Reza? The answer is no. We could ask Jorge, are you Reza? The answer is no. We could ask on, are you Reza? The answer is no. And once we get to the end of, the array that we're looking at, the list of potential matches, then we would just return -1 because the answer was no all the way through. So -1 to mean this, search target is not on the list versus the position in the list if it is. Okay. It's kind of like that Dr. Seuss book, Are You My Mother? And he goes up, do you remember that one? Or it's like, maybe it's Dr. Seuss. He goes up to it's like a bird who lost his mom. He goes up to like a tractor and he's like, are you my mother? And then he goes up to I don't know, the next thing. Are you my mother? Sorry? Oh, what a sad ending. I forgot. He doesn't find his mother. Oh, wow. Okay, that's good. Oh, yeah, okay. Well, cool. Okay, so that's so that's kind of an analogy that we can use here. The sequential search algorithm uses a loop to step through each element in an array comparing each element with the search value and stops when the value is found or the end of the array is reached. So if we set up a string array using initialization lists like this, uh, then we can make a sequential search algorithm. Which will take in a string that is going to be the target value, so like the string that we're trying to find. The algorithm just considers each element in the array, just use NetBeans instead. Okay, this is painful. Okay, yikes. So here's our algorithm. Uh, the idea is we step through each element in the array, starting with To Kill a Mockingbird. That's books at position 0. And we see if it equals the target. If that's what we're looking for, then we'll return we'll return the 0, the position of that book. If we were looking for the King James Bible, then we would have skipped that if statement and then start the next iteration of the loop. In this case, we'd consider books at position 1, and we'd see if that equals the King James Bible. If it is, we'll return position 1. If it's not, we'll do a third pass. We'll check out whether a brief history of time matches, the search item. Yeah. Oh, whoops. Yeah. Good call. Good call. Yeah. And if we were looking for a brief history of time, then the first 2 books would match, but the third one would, and so we would return 2, the position of a brief history of time. If none of the books matched, then we would just go through this whole for loop, but we would never reach the return statement. Remember the return statement, if it runs in a method, then the method's over. That's it, you know? So if we never get to that point, we make it all the way to this statement at the very end of the method, return -1, meaning, hey, we checked every item in the list, wasn't in there. So we'll return -1. And that's a good return value because if we were expecting an index and we got back -1, well, -1 can't really be the index, you know, because they're always like 0, 1, 2, 3, 4, so they're non-negative. So then, yeah, -1 is going to indicate, hey, we couldn't find it. Okay, so we can run this in NetBeans, and someone, do you want to pretend like you're at a library and you want to find a book? It could be any book, doesn't have to be one of these three. So we're in NetBeans. Project, call it sequential search, or we could just call it search array. Sequential search also goes by linear search. You might have heard it called before. Oh, whoops. Cool. Put books in the main method. It was just kind of like floating on its own outside any methods. It was like a global variable. That wasn't good. So let's make it just a local variable inside books. And then let's see here. Oh, okay. And then this is actually trying to reference books at position I. So one way to fix this would be to pass in the array also to sequential search along with the target. Does that make sense? Or so in other words, to change the parameter list so that it actually has two parameters, a string array called list, and then to just reference list here. Because if books is declared up here, then we wouldn't have access to it down there. Okay, but I think those are the only changes that we really would have to make there. And then what we could do is we could just ask the user, okay, what book do you want to search for? And then we could call the sequential search algorithm, passing in books and their target. Yeah, yes. Yep, good call, good call. Yep. Did everyone get that? So yeah, if we had 2 copies of To Kill a Mockingbird, this would just stop at the first one. Yeah, yeah, good call. Yeah. Do we have 2 students with the same name? We have 2 Nicks, don't we? Yeah, so if we had done this and we had our 2 Nicks in here, yeah, it would have just returned wherever the first Nick was sitting. Yeah. Okay. So this is kind of review. We could make a scanner, call it SC equals new scanner based on system.in. We could print out, what do they say at libraries if you're searching for a book? Inner book title or something? That doesn't sound. Book search catalog. I think I'm making it worse. Okay. And then let's go ahead and read in that string. Just call it anything str. Call it lookup maybe. String lookup equals sc.next line. And then we can call sequential search and store the result to some int that's going to have the index or -1. And then we could print out the book is at position, plus result. If it's found, if result is not equal to -1, print that out. But otherwise, print out, the book is not in the catalog. Not found. And then I'll just let NetBeans import the scanner class for us. Java.util.scanner. And here's kind of the main, here's the main method. And kind of the big idea is calling our sequential search. So did someone think of a book they wanted? Okay, cool. Was that on the list of like banned books at some point? Books better burned than read? Okay, cool. Which now it's like, yeah. We'll run this. Did anyone need to see any other parts of this, by the way? I'll put in the notes, but just for now. Okay, so the catcher, is it the catcher in the rye? Or is it the catcher in the rye? Okay. The book was not found, but that's good, right? Because, I mean, for the purposes of our program, that's good. Right? Should we run it again and try To Kill a Mockingbird? Cool. Okay. And our book title, the search catalog, To Kill a Mockingbird. Okay. Like the book is at position 0. Cool. First item. Okay. We use equals ignore case, so we don't have to worry about like upper and lower case stuff. Should we try one? Maybe we could try To Kill a Mockingbird again, but like all caps or something. Okay, cool. This. Okay. And it looks like it's still found at the same place. Okay. So that's a nifty search algorithm, and it works. Okay. So then very briefly, let's go ahead and take a look at the next section, 7.9. Oh yeah, sure. Yeah. Okay, yeah, sure, no problem. A two-dimensional array is just an array with rows and columns. So if we have these, let's say 4 values here, 2, 5, 11, and 3, they could be in an int array of int arrays, or a two-dimensional int array. If the int array is called B, yeah, int array, yeah, and it's kind of funny because it'll be a double curly braces, to declare it, yeah, So the way to declare it would actually, if you're using an initialization list, use 2 arrays, but each array is an array. The first array is 2, 5, so really just the first row. The second array is 11, 3, so really just the second row. The indices, instead of just having one index, you actually have 2. The first one is for the rows, the second one's for the columns. They still start at 0, but up here in the upper left, really we have at position 0, 0. Oh, good question. Because it's in row 0, so here's row 0 and here's row 1, and it's in column 0. Here's column 0 and column 1. Yeah, that's a really good question. I should have mentioned that earlier. Yeah. The rows always come first, so the 5 is like B, and the subscripts are, well, row first, so row 0, and column second, so column 1. What are the indexes for this 11 down here? Cool, yeah, because it's in row. Oh, actually, is it 0, 1? 0, 1's this is the 5, actually, from up here. And they're all going to be different. Yeah. Say 1. Cool, which in row 1, because here's, the rows, go horizontally, so it's in row 1. And what column is it in? Column 0, yeah. And then the 3 is at position where? 1 and 1, yeah, Row 1, column 1. Yeah, absolutely. Absolutely. Yeah, totally. Good call. Or a game. Uh-huh. Yeah. Cool. Jesus. Yeah. But yeah, to keep track of, yeah, like maybe quarterly sales data. So you have like maybe a bunch of products and a bunch of quarters and you track, both. Yeah. So two things at once. Yeah, whether it's X and Y coordinates or whether it's uh, quarters and products. Yeah. Cool. And if you had quarters, products, and a bunch of years, then that could be a 3D array. Uh-huh. Or X, Y, and Z coordinates, for like a graphics program that would have stuff in 3D. Cool. Let's go ahead and turn this into a quick Java program. Public class 2D arrays. Actually, let's change that. Two-dimensional arrays. Let's make a main method. Let's declare our 2D array called B, and let's put in a 2, and a 5, the 11, 3. And then let's loop through. Now here we will need a nested for loop. Well, a nested loop. Doesn't have to be for. And it'll be really similar to processing our 1D arrays. But for each of the 1D arrays, we'll process, for each of the kind of rows, we'll process the columns. And for columns, sometimes people go with J. So for int J equals 0, J is less than B, or actually, J is less than B at position I dot length. J++. And then we can print out B at I, J, and space. And then we can print out just a blank line. So a lot going on here. What do you think the output's going to be? Oh, sorry? Yeah, it'll print it like a table. Yeah, good call. Good call. Yeah, nice. Yeah. Okay, cool. So let's go ahead and run this. We're in NetBeans. A new project. Call it two-dimensional array. You can just replace the class and everything. Okay, get rid of some of this stuff. Okay, and so, did we get this? Oh, too many. Oops, my bad. Okay. So yeah, really this, system.out.println, it's in the outer for loop, but it's not in the inner for loop. And that makes sure that a new line is printed after each of the rows is printed, then let's print a new line and then start the next row. But between, the columns in a single row, we'll just print a space. Yeah. So it's kind of cool. I realize there's a lot going on in it. Any questions about this algorithm, which should work for any 2D array, even if if it's like ragged where there's like 2 elements in the first row, then 3 in the next row, then like 2 in the third row. It should just print out all the elements. Okay, cool. Let's try it out. And then maybe we can play around with it if anyone wants to test out anything. Oh, I think I clicked the wrong thing. Oh, interesting. Okay. So we run it, and actually things are looking kind of weird. 2, 5. Oh, okay, and then 11, 3. And that's actually, I made a mistake. Does anyone see what can be done to fix this? So that they do print out as a table. Yeah. Nice. Awesome. We've got a print line here that shouldn't be there. Yeah. Awesome. Good catch, John. Okay. Nice. Okay, sweet. So that looks a lot better. Okay, does everyone understand that? Jiang's answers right now to change the print line to just a print? You got it? Okay, cool. Nice. Awesome. So yeah, keep in mind I is going from 0 to 2. Well, yeah, 0 and 1. And then j is going from 0 to 1. So we'll print out 0, 0 first. That's the 2. And then we'll print out 0, 1. That's the 5. And then we ran out of j's, so then we'll print the new line. And then we'll print 1, 0 next, which is the 11. And then we'll print 1, 1, which is the 3. So if you follow the i's and j's, that's a good way to kind of track what's going on and trace out the results. Yes. X and Y, A and B. Yep. Anything. Yeah. Okay. Sweet. Any other questions? Okay. Thanks, everyone. Sorry that I didn't take the time to consider it.